The question of whether other life exists somewhere else in our universe has been debated for the better part of our human existence, but has become more hotly debated over the course of the last century as our technology has advanced. Frank Drake was an astrobiologist in the mid-1900s. Astrobiology is the study of origin, evolution, distribution, and destiny of life in the universe. Drake wanted to create a way to estimate the chances of there being contactable, intelligent life somewhere else in the universe. In doing so, he created a 7-variable equation to make his estimate, which we now know and call the Drake equation. The first variable of the Drake equation is R star, which stands for the rate of star formation. This number would be very large because we know that there are hundreds of billions of stars in every galaxy, which there are hundreds of billions of galaxies. After R star, there is F planets, which stands for the fraction of stars with planets. This number would also be very large, as in the relatively few stars we've studied, we have already found thousands of planets orbiting those stars. The next variable is NHAB, which stands for the number of those planets that are in the habitable zone, being at the right distance from their star to support life. This number would be lower than the other two so far, as not many of the stars we discovered are in the ideal zone of habitability. F-life is the next variable, and F-life stands for the fraction of these planets on which life exists. This number would be large because Earth has existed for an estimated 4.5 billion years and has fostered life in about 3.5 billion of those years. In these years, Earth has had life in very extreme locations, like 7 miles in the ocean where no sunlight reaches, and at temperatures well above water's boiling point. The next two variables are very selective filters which lower our chances of contacting life greatly, though not completely destroying them. The first of these variables is F-intel, which stands for the fraction of these planets in which intelligent life emerges. This is likely a lower number because Earth had 3 billion years of single-celled life before anything that could be considered intelligent arose. The next of these great filters in the Drake equation is F-tech, which is the fraction of these planets on which technological civilizations arise. This is necessary in order to communicate with another civilization. This number would be low also because Earth did not evolve to this level until about 1950 AD, roughly 3.5 billion years into our evolution. The final variable in the Drake equation is L-time, which is the length of time these civilizations can emit signals into space which we can receive. We know our species of human only has so long here on Earth before going extinct, and other intelligent species would likely go through a similar timetable before their own extinction. All of these variables make up the chances we have in discovering contactable intelligent life somewhere else in our universe.